Hello everyone, this video presents A12 batch. The A12 batch members are KS Kirtana, R Kirtana and A Dachayani. Now in this video, I am going to explain about encoder and decoder and also will see its operation by using a multi-sim simulation. First encoder. Encoder, it is a combinational circuit that converts binary information in the form of a 2n input lines into n output lines. Then this encoder have 2n input lines and 2n input lines and n output lines. If n is 3, we get 8 input lines, 8 input lines and 3 output lines. Here we have 8:3 encoder block diagram. D0 to D7 is the 8 input lines. XYZ is a 3 output lines. Then we will see the truth table for encoder. And D0 to D7 is the input line. XYZ is the output line. The binary representation of Z is 1, Y is 2 and X is 4. Now if D0 is enabled means we will get no output from XYZ. If D1 is enabled means we will get output from Z. If D2 is enabled means we will get output from Y. And then D3 is enabled means we will get output from both Y and Z. If D4 is enabled means we will get output from X. D5 is enabled means we will get output from both X and Z. If D6 is enabled means we will get output from both X and Y. If D7 is enabled means we will get output from all, that is X, Y and Z. Z is 1, 2, 4. Totally 7. If D7 is enabled means we will get output from all, that is X, Y and Z. Now we will write Boolean expression for X, Y, Z. Now we will write expression for X. If D4 is enabled means we will get output from X. And then D5. In this place only we will get output from X. D6 and then D7. And then Y. We will write Y. Boolean expression for Y. That is D2 and D3 and D6, D7. D2, D3, D6, D7 is the Boolean expression for Y. In this place only we will get output from Y. And then Z, that is D1, then D3 and then D5 and then D7. This is Boolean expression for Z. And then here I have already written the Boolean expression for X, Y, Z. By using this Boolean expression, we are going to construct logic diagram. We have three outputs, right? X, Y, Z. So we use 3 OR gate. Why we use OR gate means we have addition operation. So we use OR gate. If multiplication means we use AND gate. And then D0 to D7 is a 8 input line. Now we will connect the input lines. For X is D4, D5, D6, D7. So D4, D5, D6, D7. These 4 lines are connected to the X and then Y. And then Y. Y is D2, D2, D3, D6, D7. These 4 lines are connected to Y. And then Z. Then Z, that is D1, D1, D3, D5, D7. These 4 lines are connected to Z. This is the logic diagram for encoder. Now we are going to see Simulation. For encoder simulation, we need IC, probe and switch. First, I will take IC. So, go to sources, and then choose all groups and choose 74LS IC. We need 74LS32D IC. Click OK and get the IC. And then I need probe. So go to indicators, then move on to the probe and get it. And then I need switch. So go to source and then digital sources, not this. Go to sources, digital sources, and we need interactive digital constant. Yes, I get it. And then here I already connected the encoder circuit. Now just will simulate. Here Y0 to Y7, 8 input lines and ABC is the output line. Our binary representation of C is 1, B is 2, A is 4. If I enable Y0 and then we'll just run, we get no output from ABC. And then enable Y1, we will get output from C. And then if I active Y2, I will get output from B. Yes. And then if I enable Y3, I will get output from both B and C. Correct. If I will enable Y4, I will get output from A. Correct. And then if I will enable Wi-Fi means I will get output from both A and C. Yes. And then Y6 means I will get output from A and B. Yes. And then I will enable Y7 means I will get output from all, that is A, B and C. Yes. This is all about encoder simulation. Now we will see the concept of decoder. Decoder is also a combinational circuit. A decoder accepts a set of inputs that represents a binary number and it activates only that output corresponding to the input number and all other outputs remains inactive. Then some decode have one or more enable lines that are used to control the operation of decoder. Enable lines that are used to control the operation of decoder. We will see the block diagram of decoder. Here decoder have n input lines and then 2n output lines. It have n input lines and 2n output lines. If n is 2, we have 2 input lines, 4 output lines. Here we have 2:4 decoder block diagram. AB is a input line, D0 to D3 is a 4 output lines, and we will see the truth table. Here AB, that is input line, 0 0 is a 0, 0 1 is 1, 1 0 is 2, 1 1 is 3. Yes, D0, D1, D2, 3 is a output. If 0 0 means we will get output from D0, 0 1 means we will get output from 1, 1 0 means we will get output from D2. If AB both enable means we will get output from D3. Then now we will write Boolean expression for D0, D1, D2, D3. Here we have 4 output lines, so we have to write 4 Boolean expression. In encoder we have three output lines, that is x, y, z. So we just write 3 Boolean expression. Here 4 output lines, so we have to write 4 Boolean expression for D0, D1, D2, D3. First for D0, D0, D0 is equal to, here 0, 0, 0, 0 means both are complement, A complement, A complement, B complement. D0, D0 is equal to A complement and then B complement. And then for D1, the Boolean expression for D1 is A complement, here 1 is uncomplement, so B. A bar B is the D1 Boolean expression. For D2 is A B bar. It is the Boolean expression for D2. And then for D3 A B. It is the Boolean expression for D3. Here we write 4 Boolean expression for D0, D1, D2, D3. And then for using these 4 Boolean expression, we have to construct the logic diagram. Here 4 AND gate, this D0, D1, D2, D3. We use 4 AND gates, 2 input lines A, B. Here we use inverter for complement. This A complement, here B complement. We use inverter for A bar and B bar. Then we will connect. For D0 is equal to A bar B bar is the Boolean expression for D0. So here A bar, here B bar, and then D1 is A bar B, A bar B. D2 is A and then B bar. D3 is A and then B. This is the logic diagram for decoder, and then we will see the simulation for decoder. Here I already constructed the decoder circuit. Now I just simulate. First we will enable the enable line, then just run it. The input line, that is A and B. A and B are 0, 0. 0, 0 means we get output from D0, and then 0, 1. 0, 1 means we will get output from D1, and then 1, 0. 1, 0 means we will get output from D2. 1, 0 means we will get output from D2. Both 1 means A and B, both 1 means we will get output from D3. Yes, D3. This is all about decoder simulation. Hope it is little helpful to all. Thank you everyone.